Okay, so we have this problem. Construct a table and find the indicated limit. Now we're kind of jumping around here. Uh, just as a side note for this, assume all trig functions' independent values are in radians. So what that means is put your calculator in radian mode. The only way we're going to do this with the table, we're not going to do this by hand. We have to use a calculator for this. Okay, so I'm going to jump over to this software here so that we can look at the graph of this tangent 2x over x. First thing you want to do is go to document settings, make sure you're in radian mode. You might be in degree mode from this last unit. You want to make that radian mode and you want to click make default. Okay, that's first and foremost. Now here, let me get this out of the way. Here what we're going to type in is our tangent function. So we're taking the tangent of 2x, up here, my bad. So we're taking the tangent of 2x and we're dividing that by x. And when we graph this, we'll get something that looks like this. Okay? So when you're looking at this and you're seeing this function, now go back, let's look. We're taking the limit as x approaches 0. So the limit of this function as x approaches 0. So if you zoom in here, you see all this stuff over here, you see all this stuff over here, that's kind of immaterial, it's irrelevant, because we're only concerned with what's this function look like it's approaching as the x values get closer and closer to 0. I'm going to zoom in probably just one time here. We don't need to do much more than this, but we can. So here we go. So we've zoomed in on this one point. Now, as you go to, let's see. Oh, here we go. Trace. If we want to trace this graph now, focus down here at these points. So graphically speaking, as these x values are getting closer and closer to 0, what's happening to these y values? Right? So as these x values, negative 0.45, negative 0.4, negative 0.3, these are getting closer and closer to 0. What are these y values doing? What's the value of the function approaching? And you're probably like, why are you wasting your time talking to me right now? It's obviously approaching 2. And that's what we see from the left. Skip over real quick from the right. As we approach, again, looking at the x values here, and the y values. As these x values get closer and closer to 0, what are the y values getting closer and closer to? 2. So we can go back here and definitively say right now that the limit as x approaches 0 of this function is 2. All right? Notice what I skipped over. I skipped over the point where we got to 0. Because when x equals 0, the value of this function is undefined. Why is that? Because this can't be 0. I can't put a 0 here and evaluate the function. It'll tell me it's undefined. But again, I've said this a few times now in some of these other videos. It's not about what the function equals at that point. It's what do the y values appear to be getting closer to. They appear to be getting closer to 2. From this side, they appear to be getting closer to 2. So that's why our limit is 2. Even if the value of the function is undefined at this value of x, the limit can still exist. That is crucial to understanding limits.